in your study, did you look at the current water losses at users before we talk of recycling what has already been used? Did you look at all existing study results on the water losses?
Okay, thank you very much for the good question. I have several colleagues who are doing or who did what you have asked, like assessing water losses for the used water supply system. The losses are there, yes, but this idea is trying to limit or to minimize the amount of groundwater which is being pumped, so as to save our finite groundwater resource. Because from the studies which my colleagues did, some other colleagues, it has been found that the water table drawdown for our groundwater resource, especially during summer, is too excessive. To such an extent that we as the faculty engineer or as students, civil engineering students, we are now hearing that what will happen after, later, or if our groundwater resources rise up. So we are trying to minimize the amount of water which is being pumped out from the ground, so as to increase the lifetime of our groundwater resource, save the investment as well.
Is there any burning questions, preferably from you? There's a lady up there. Just give that lady, she's got a question. Please be brief. Thank you.
Thank you very much for your wonderful presentation. I just put up something. You're talking about grey water, you're talking about washing groundwater. You say that there's something to do with nutrients being recovered. So I'm a bit worried when you need to recover nutrients from that water, or maybe I can see later.
Okay, thank you very much. I'm saying that there will be nutrient recovered if the effluent is used for irrigation. Yes, for irrigation. So, take for example, let's say you own your home and you are irrigating your lawn using treated grey water. Instead of you buying a 50 kilograms of fertilizer per year or so, if you use grey water, you will save that money because grey water is rich in nutrients. And what I was trying to explain. Thank you.
That's the presentation from Congress Fellow, and thank you very much, young man. You may take a seat. Thank you. I just wanted to advise our presenters, please, we just want to make it easy for you so that you can look at that sign and look at that screen. And also, we can use this microphone that I'm using now as a roaming mic so that it doesn't have to go on a stand and you can talk freely. Our next presenter is from the Department of Electrical Engineering, Gerald Chihoyi. Thank you, Gerald. Can you come forward, please? How many of you know tomatoes? You know tomatoes? So I'm talking to the right crowd. As I grow up, we used to make a living from tomato farming. But every day we go back to tomatoes home and we sell it at a lower price because we are afraid that they'll vote. So that pains me a lot because I wish that was as good. And I know there are a lot of people here who are raised by farming. So agriculture is big. Agriculture is a big part of the economy right now in Zimbabwe. And about 66% of the Zimbabwean population are farmers. And 3 million of them are small-scale farmers. They put a lot of work to farm tomatoes so that they can bring food to the table. That's because for them tomatoes, that's their dream of financial independence. That's their hope. That's their hope until they are working the reality of post-harvest. These are tomatoes. Great quantities are go around the world again and they food disease. According to World Health Organization, 2015, about 600 million people in the world fall sick every day after consuming contaminated food. 420,000 of them die because consuming contaminated food. The food dealers, right now, the preference of consumers is shifted towards health and tasty foods which are available. But the challenge we have right now is providing such food in a form suitable for distribution and mass production without affecting the texture, flavor, and the color of the produce. It's technically complex. Current methods that are there for preserving tomato are consumer related. They cannot be used by the farmer because, as I mentioned earlier, the preference of the consumers is shifted towards health. People now want health and taste tomatoes as they are. Dried tomatoes are considered as a poor man's activity. So, also, other farmers, they use chlorine to disinfect or decontaminate their produce. But however, chlorine is a carcinogenic substance. And in countries like Germany and Switzerland, it has been banned. Also using water to wash the tomatoes or the fresh produce is also this limitation. For example, there is possibility for cross-contamination. Bacteria can move from one fruit to the other. So, what is the solution? Ladies and gentlemen, I'm going to you the groundbreaking solution before we have the plasma. I know most of you are familiar with 3 states of matter.
solid, liquid, and gas. But do you know that there is the fourth state of matter? There is the fourth state of matter. As you keep on increasing energy from solid, liquid, gas, you reach the plasma state. In plasma, what it is basically is it's ionized gas. It is electrons, ions, and free radicals. And these radicals are the ones that attack the bacteria and strip the protein membrane of the bacteria of their hydrogen ions, and therefore killing the bacteria. And that's how we kill the bacteria from. That's how we kill the bacteria. So they are probably more familiar with plasma directly, because lightning itself is considered as plasma. That's why you can feel that freshness after lightning strike. The lightning ionizes the air that is in the atmosphere, and therefore feel that freshness. Also, our processes, they grow because of plasma technology. Most of the plasma material they are all that plasma as well. The sun is considered also as plasma. So this is how plasma. This is plasma. This is high voltage, which is ionizing gas, and this ionized gas now attacks bacteria or microorganisms, and that's how they kill the bacteria. So what exactly are we talking about? Process does not use it to kill the bacteria, but use the reactivity, as I have said earlier. So we are just taking this, technology from other existing applications all around the world. Cold plasma is used in treating cancer cells, treating wounds, and sterilizing medical equipment. So what we need to produce plasma is we need energy. Let's say we need to sterilize, we need to ionize our gas, so we need energy. So we can use electricity, microwave, laser light or radiation. We also need a carrier gas. For example, I'm using air, you can use nitrogen, oxygen, or helium, because those are very expensive. The output is so quick in plasma. In other words, if you don't do anything with it, it will just recombine. So the design of cold plasma, I have a microcontroller here. Microcontroller connected to a digital humidity temperature sensor for detecting or for maintaining the temperature in the humidity cold plasma chamber, because you don't want the humidity to change. So we want to maintain the temperature as well. I'm also using the transformer, the flat transformer from old television, and that's the one that produces the highest voltage. Actually producing 20,000 volts. I also use a buzzer and the main machine interface. I have the remote and also a display in the door sensor, so that this is high voltage, so you don't want someone to put his hands while the plasma is operating. So these are the pictures of the prototype that these are the second. So So this is the cold plasma chamber. Actually, just a main. You can preserve your tomatoes, your apples, or your seeds. Because you can use cold plasma technology to disinfect seeds so as to increase the germination. So what you do is you click one. If you want to preserve the tomatoes, then you enter the mass here. After entering the mass, you upload the mass, and then it will be communicated to you. You see on the screen. So basically, these are tomatoes. I was preserving tomatoes to test how it works, whether the texture or it's not affected as well as the color of the tomato. So this is 20,000 volts. So when it is done, it notifies you that. So I was testing tomatoes to see if they are not germinated by the high voltage. They were not germinated. So where is the man? Actually, so the production post the heat. Actually, I have this as a prototype, but I'm scaling it up as a model. This is actually 40 centimeters, but 40 centimeters by 8 by 12 centimeters height. But I'm planning to scale it up to something. This is a 2 meter by 1 meter, 2 cubic meter. And actually, this is the cost of producing it. But if you are producing it, if you are producing a lot of them, it's actually cheaper. It may cost about $8 because in electronics it's a volume of business. So for a farmer with a 1 ton of tomato, the loss for a farmer without cold plasma loses about 40% of the tomatoes. But with cold plasma, I can also lose 45%. Because with cold plasma, I increase the shelf life by 10 days. Actually, it's 5 to 10 days to spend on the design of the cold plasma. So you can see it's different. Conclusion and recommendation. So the cold plasma has been developed as you can see. So we're now starting to scale up. And also, let us implement this technology in agriculture and our hospitals. I also recommend reverse engineering in our country, Zimbabwe.
Cold plasma. Can we have any questions? We have 5 minutes for questions. 1, 2, 3, 4. Only those 4 questions, please. Please be brief. Can we have the microphone? Where is the only microphone? Thank you. Just start at the top there. Yeah, okay. Go ahead, sir.
You have a very interesting project, and I think it's very innovative. I've got 2 questions that I've got. The first question is, what plasma gas can you just use for your plasma generator? And the second one is, how selective is your cold plasma towards the bacterial proteins? Because if it's not very selective, it means the very same thing that kills bacteria can damage the beneficial chemicals in tomatoes. So, how selective is the cold plasma? And if you characterize the effect of that cold plasma on the nutritional components of the tomato. Thank you.
Okay, thank you for the question. I didn't hear the first question, but rather the second question. Rather the second question. There are other, like a cold plasma is in the research and development phase right now, and a lot of work has been done to prove that it does not affect texture, the aroma, and the sense, as far as the sense of nature of the tomato is not affected. And your first question, can you come?
What gas are you using as your cardiac gas?
You are using, yes, because it's just cheap in this like
There was one guy, yeah, the gentleman over there. Okay.
My question is the operation costs of this chamber, like your electricity cost. How did you analyze your electricity cost as to the amount of money that you'll be saving for not using your tomatoes? Is it are you really saving?
I'm using a 4-volt battery, so and the current is about 4 amps, which is about 48 watts. So it is equivalent to a light bulb. We are using so as far as energy is concerned, we actually save.
That was a very good presentation, but my question comes to the medical side. You said this can be used in the hospitals. How exactly do you postulate that we can use it in the hospitals? Because I'm interested in the medical field.
Okay, thank you for the question. When the medical field can be used to sterilize medical equipment, and also we can design it not as a chamber but as a plume to in dentist to remove that substance or what they call the plaque. Okay, that's how we can do it.
And we have our last question to somebody in the center there. All right, just that gentleman there, please. Thank you.
I'm very impressed with the technology, but my question is, we also have fridges which are capable of doing almost pretty much the same thing of preserving fruits and food. So if you may please tell us, I need to know more, like how your benefit, how your technology compares with the current fridges that we have.
Can you come again?
Okay, yeah, we also have fridges, like refrigerators, normal refrigerators, and they are also capable of preserving tomatoes, like the technology we have there. So I want to know between refrigerators and cold plasma, how is cold plasma more superior to refrigerators?
Okay, thank you for the question. We are targeting commercial farmers. So, like I said, the current methods that are refrigerator are mainly consumer methods. For a commercial farmer to use the refrigerator, it is very expensive, and also the consumer preference. If you put tomatoes in the refrigerator, they become smashed, so they cannot be accepted by the consumer. But if the consumer is using the refrigerator, so there's no problem. But if you are buying the tomatoes from the farmer now, from a refrigerator, you won't buy them. That's why you find in the supermarket, the tomatoes are not put in the refrigerator. That's the reason, because come and the root that
Old plasma technology from Gerald. Thank you very much, Gerald. Our next presenter is from the Geoinformatics and Surveying Department. And it's Wellington Joe is going to talk to us.
What happened to me when I finished my Form 6 level. I studied very hard and I obtained 50 points. But I had no money to go to university. I got a place at the University of Zimbabwe. Then I approached one of the local doctors in our area. I live in rural areas. So that doctor sympathized with me and she gave me money for school fees. So I now have school fees, but I didn't have money for food and money for accommodation. So I lived with my uncle because I'm an orphan. So my uncle took these 2 goats, the only goats he had, and he used those to, he sold the goats and gave me the money to pay for accommodation and for food. Then I came to use it. The money was not enough to cover accommodation. So I had to stay out of towns. And that's me. I was walking around looking for accommodation. And I was moving from place to place, knocking on people's doors. And there you can see I was very tired. That's when I met another guy who pretended to be willing to help me. And when I met this guy, he told me he had accommodation. And unfortunately, somehow, I lost everything. He took my bags, he took the school fees, and everything. Because I was looking for accommodation using this system. So I am Wellington Ngoma, and I come from the Department of Geoinformatics and Surveying, and I'm here to present my project entitled Online Off-Campus Accommodation to University of Zimbabwe Students. So this is what I'm going to cover. I will give a project overview, then I will give the current status of things, then lastly I will talk about what I'm looking forward to see. So on the project overview, I will just give my main objective, then the current status of things, I will give what I've covered so far. So as an introduction, like I said, my main objective is to develop a web-based online application which can be used by students, to look for off-campus accommodation. And the driving factor or the motivation behind this project is the fact that UZT has about 18,040 students. And it has 11 hostels with a carrying capacity of 6,100, which means 11,940 students, they cannot stay on campus because the accommodation is not there. Also, let's say you are doing the degree program, which I'm doing surveying and geoinformatics, like I said. We are required to pay $780 if we have a survey camp that semester. And if you want in accommodation, you have to pay $150 additional for accommodation and food. That's the total is 1,163. And like I said, I'm an orphan and I cannot afford that kind of money. For me to get accommodation, I have to pay all that for getting the accommodation. So, all right, sorry for that. This is what is being said by quite a number of newspapers. Those are just sample newspapers. One of them may be that one which says youth and students squatting like rats. Those ones and accommodation goals, Western usage. Those are just comments from various newspapers. So in our current system, let's say you want to look for off-campus accommodation. You have to travel all the way. Let's say you stay in Bulawayo. You have to travel all the way from Bulawayo. You come here to Harare, you search for accommodation and how to use it. After getting the accommodation, you go back to Bulawayo again. Then when schools open, you come back. Or if you try to change that way of looking for accommodation, you can go through agents who can help you to look for accommodation around campus. And usually, like I said in my introduction day, I ended up losing all my belongings. Those are fake agents. So you have to carry your bags and move around looking for accommodation like that and looking on people's doors asking for accommodation. So what I'm saying is we must stop wasting time and we must stop wasting money using this current system which is being used. So I came up with a research plan in designing a new system which can be used. And obviously I did a user needs analysis based I first studied existing systems analysis. I wanted to know what is being done in other systems. Then a user needs analysis is to know what the users need. So I talked to user students, mentors around users, to use the accommodation offices to know what they need. So that way I was collecting my data. Then I designed my system. I did a database design to collect all the accommodations and all the vendors around users and the accommodation and the admins and accommodation offices. Then I designed my databases which I use for the system. Then a website template where I embedded those databases. So I then tested if the prototype which I was designing was now perfect. And if it was not perfect, I would ask students to use the system. Then if it was not perfect, then I would modify the system until I came up with online off-campus accommodation. So as my results, the first thing is I gave 100 students online questionnaires. And from those questionnaires, I realized that 23% of the students, of the 100 students, they are staying on campus, but actually the students who want accommodation on campus, 73% on your right there. So it means the other 50%, they have to stay off campus because they cannot stay on campus, either because there is no accommodation or they cannot afford to pay for the accommodation. So from that statistics, I then asked the students a question. If you are looking for accommodation, what do you look for? Then 97% they said they want places close to use it, they want places with less rentals, safe areas, available facilities. That was 85%. They will be checking like if there are beds, internet, and so forth. So they check all the available facilities there. So in designing a system, we have to consider all the people who will be involved in such a thing. And I also asked the landlords who offer the accommodation and the admins use it, who manage accommodation and use it. I did interviews and discussions with them. Then after that, I then realized we needed an online system which can be used by users, students to look for off-campus accommodation. And it has 3 interfaces. The interface for students, then another one for landlords, then another one for users admin. That's the interface. And welcome to our new system for looking for accommodation. So if you are a student, you have that as your home screen. You can search the top there 4 times where you can search accommodation only, or when there is accommodation and food, or when there is accommodation, food and transport. Then you can also specify the place you want. Let's say you want a non-pleasant, know the area, and you specify that. And latest accommodations will be displayed below that search field. Then after clicking search, you are then displayed with an interactive map which shows all the accommodations within your search range. And there's also that form, and so it's not clear because of the setting up here. That's a search form there which you can also use to restrict your search. Let's say you want accommodation which occupies maybe first year students, you can search there. Then on that map it's interactive, you can get more details about the accommodation and you can also get direction. So having this, after clicking search, you get the accommodations within your search range. And if you click details on that map which was up there, you get the details for the particular accommodation which you have selected. You get the cost, the rental, monthly rental, the name of the accommodation, the address, you get pictures, and you also get the features which are on the accommodation, and you get the description of the accommodation. Let's say it's only for first year students or master students, it's stated on the description of the accommodation. And let's say you are now interested in booking the accommodation, you are then given the details of the landlord. Then you also get a form which you can fill. You write your name, your phone number, your email address, and the message. Then you send to the landlord. And also, I said I'm doing geoinformatics and surveying. And let me maybe define what surveying is. It's the art, science, and technology of positioning things. So I was in this system, if a landlord posts an accommodation, it is automatically shown on a map like that one, and if you click get directions, the accommodation is there on your far right. So it's that one in red there. Then if you type where you are coming from, or if you click on the map where you want to come from, whether it's you said or from your home, you are then given the directions. And if you are driving, that's a route for drivers. And if you are walking, that's a route which is following footpaths. Then that's the interface for students. But this system has 3 users. So now let's talk about the landlords. The landlords can log in into the system. They have to have an account. After logging in, they can post an accommodation. So there you can post your accommodation. You will be asked questions. Then you just fill in the text boxes. Then you can put photos. You can have those internal notes where you comment specifically on that accommodation. Internal notes are not visible to users. They are just for the landlord to see. Then you submit your accommodation. And if you get inquiries, they are classified into 3. There are new inquiries, there are inquiries which are being processed, and there are processed inquiries. So new inquiries are the new messages which are coming from students. And if you are now talking to the student, you can put the inquiry under inquiries being processed. And if you give the name to the student accommodation, then it becomes a closed inquiry. That's a processed inquiry. Then, if you want to get more information about an inquiry from a student, you can click details on any inquiry, then you get more information about that inquiry, the time you are sending a message, phone number, email, everything. Then, just like on Facebook or WhatsApp, you must be able to update your profile. Let's say you want to change your name, etc. You can do it on update profile there. Then you can also change your password. Then if you put a weak password, the system will reject. It requires a password with both numbers and alphabetical letters, then capital letters and so on. So it will reject other passwords. Then if you forget your password, there's a password recovery system there, which you can just type your email address, and then password recovery link is sent to your email, and you can reset your password. So that was the side of the landlord, but I said we have 3 users, students, landlords, and admins. So now let's go to the admin side. The admin is capable of doing all that which is done by the landlords, so users will be seeing all the accommodations which are being posted. They can also post accommodations if they have accommodation outside campus. Then, in addition to that, They also see the list of all available landlords. So that's the list of landlords. I just put about 7 landlords there. And if you click on any one of those landlords, you get the proper information for that landlord, and you can deactivate the landlord. Let's say it's no longer available, you can deactivate them, or you can update information. Let's say you have a landlord who is not computer literate, you can also update things for you or here. So this is the system which I am proposing for usage. Thank you very much. I am willing to
We have time for 5 or so questions. There you are.
Thank you very much. My question is on security. What's the vetting mechanism put in place to ensure that unwanted or unwarranted fake labels are not access to the system?
Thank you very much for the question. On this system, I had 2 options. I could make the landlords capable of creating their own accounts, then they start posting accommodations. But for security reasons, I made sure that usage accommodation offices will register the landlord. So if you are a landlord, you come to use it, the admin will create an account for you, then you will give them a password and everything. Then after that, you can then start posting your accommodation. So you come to use it, you will bring your papers to confirm that you are a true landlord, then you can start posting your accommodation.
Yeah, I'll recognize the other person.
My question is about the functional constraint of your system. I will ask about the reliability of the system.
Please speak into the microphone.
Okay. It's about the quality constraint of your system. And I'm looking into the reliability of your system, the scalability. How does it respond if many students apply at the same time? I didn't hear about the throughput, the response from the system. And who will be running this system? And since you mentioned something about the interaction between the users and the university admin, so I want to know who will be responsible for the maintenance so that the system is reliable. And also about the servers within the special Okay, thank you.
Thank you very much for the questions. I hope I will remember all the parts of your question. But basically, this system will be managed by usage accommodation office. So they will be the managers of the system. Then you also talked about, I'm forgetting the other question.
Scalability.
The other one. All right. We also talked about if it's reliable, like if there are many users on the system. Yes. All right. For this system, I was using Casio, which is a cloud platform used for creating databases. And that platform is used by companies like HP and Coca-Cola. And it's a reliable company which is offering cloud databases like this one. So it's very reliable.
Please can I ask you to make your questions simple and try and be very specific. I have those 2 gentlemen in the top there as the last 2 questions that we have. Thank you.
My question is, I understand that it is already a system which has got a list of landlords with their phone number. what advantage does this system have over the current system?
All right, thank you for that question. You say what are the advantages of this new system over the current method which are being used? Currently, when I went to the use data accommodation office, they say they have a list of vendors available offering students accommodation. And it's a list just like I have the Excel sheets, you have the phone number, and the name of the landlord, and the address. But if you give, like I said in my introduction, I'm coming from Ikita, I'm a first year student, and I'm just told that the accommodation is at 218 on Pleasant Drive. That will not make any sense to me. You need to have that map which you can just type where you are coming from, and your accommodation is shown there. Then you are given a route from where you are coming from to the exact accommodation you need. So that's the benefit of this system, and it's also designed specifically for users. So if you check other systems like Airbnb, they cover different things. But this one you can actually search for. Let's say you want accommodation only for part 1 students. It is possible to use this system, which is not possible with all the other systems which are.
Thank you for your presentation. Since you mentioned about...
Please speak into the microphone.
Since you mentioned about time, I didn't hear you mention anything about the minimum amount of time where a student can apply to get a confirmation place. And the second thing is about optimizing your system to let's say the student gets to a minimum amount of rental they are paying. If your database gets so big, the student will not want to click all the landlords who have available places and probably just to the amount of rent they are willing to pay daily available rentals.
Your question, it's not very clear to hear you say. You are asking issue to do with the rentals.
The first question is about time, minimum amount of time.
Minimum amount of time, right?
Where the student can apply and get a confirmation.
All right, thank you for that question. If you see any accommodation which you want on this system, you can just apply right away, and it will send a notification email to the landlord's email address which is given there, and the landlord can open that email and check your inquiry. If he or she is available, he can call you, she can call you, then confirm everything, and the accommodation is put under closed inquiry and get your accommodation right there. Then I also maybe forgot to say this, the system also makes sure that accommodation which has already been taken does not appear on the system to avoid you from calling accommodation which is no longer available. So if accommodation is no longer there, the landlord will just deactivate the accommodation, not deleting it. So if you just deactivate it, it's no longer visible to students, but it's still there in the system.
Thank you. Thank you very much. Let's give a round of applause for what you presented. We are now having our 5th presentation, and our 5th presentation comes from Godfrey Mashana, who is from the Mechanical Engineering. Thank you very much.
So what you are seeing here in the screen, this is a picture of the solar photovoltaic module, or as we commonly know, solar panels. You know, these days they have become very common. We see them in our streets, we see them in our homes. They just become part of our lives, just like, you know, makeup on the face of our ladies. So you know, these devices are very important because they actually provide an alternative form of energy. All our energy is, they are clean sources of energy, not greenhouse emissions, no other, you know, negative or effects of other energy sources such as coal, and also, you know, biogas. So, what I have here on the diagram is a simplified schematic diagram which shows how the energy from from the sun is propagated by a solar photovoltaic module until it reaches this load. So we can actually split this diagram into two parts. Below the red line and called the downstream part. Now this is a classical, this is a conventional electrical energy system which any classical power energy engineer might actually design. However, the upstream part is now the reserve or the domain of solar energy experts. Why? Now this is because the energy that we get from the output terminals of the photovoltaic module, which is called the RAU, it is not constant, but it is actually a factor which depends on the climatic conditions in which the solar photovoltaic module. And now let me define what I mean by the climatic condition of the solar photovoltaic module. So when I'm talking of the climate of the solar photovoltaic module, I am talking first of all of the wind speed. If the wind speed increases, that means the thermodynamic cooling of the photovoltaic module by the wind, it increases. So what it means is that if the PV module is cooler, usually what happens is that the conversion emissions of the PV module increases. Also, the solar climate consists of the ambient temperature. When we install a PV module or a solar panel in places which are water, the emissions tend to decrease, and that means the power output against decreases. But if we install our PV module in conditions which are actually cooler, it increases, that is a result of increasing the emissions of the PV module against the power output. And also another best factor which is included in the solar climate is also the mounting configuration of the PV module itself. Is it openly mounted or is it built integrated? Is it mounted on a roof with this very insulated? Another fourth factor is now the solar irradiance, which is the primary resource of our solar energy. And that is the energy that we are receiving from the sun, the unit type and the unit area we photovoltaic energy collector. Now, for you to understand what is renewable energy engineers if you go through in order just to determine this RAU, let me take you through some of the data crashing that they are associated with. Now, the first thing we have to know is that the PV-RAU is the convolution, it's a weather-dependent convolution of the relative efficiency and the relative irradiance with the PV module power. Now, first of all, this is what we want to calculate at the end of the day. This is what we are considering, which is called our PV-RAU here. So the PV-RAU is given as the time integral of the instantaneous power that the PV module is producing. And now, here is the challenge, that power is not a constant. That power is given by that equation. When the first term there is called eta PV. Now that is the efficiency of the PV module, which is now depending on the climatic conditions. And now it is not a constant. It is depending on wind speed, it is depending on ambient temperature, conditions or variables which are changing every second. Now to make it even worse, the eta PV itself is also not a constant. And now the next question is that which is now the operating temperature of our solar panel. Now, here is the challenge, which makes it more complicated. These temperatures here cannot be readily measured, and therefore we have to correlate to other meteorological data which is readily available. For example, the ambient temperature, and to have such correlations. Now, we can see that this is the ambient temperature, and it is changing every second. This is the solar irradiance, and it is also changing every second. And now, this one we have is what is called the Ross coefficient, because this is what is called the Ross equation. Now, the Ross coefficient also, to further complicate the issue, is not constant. It is dependent upon imagine you are someone who is like me. We have got a phobia of equations that I invented the word for that, and I call that equation of phobia. Now, so this is now the problem. Imagine that the renewable energy engineer and you are given 10 projects which need to be done and they need to be completed on a given date. And you just imagine all this that you could go through this now. I mean, it's something that you really cannot deal with. But you know what? That is the reason why I am here. Let me tell you that this problem, it is not going to be there forever. There is going to be another way in which we can actually evaluate the RAU without having to go through this whole process. And let me say that, as Moses said that to Pharaoh, we shall never see these Egyptians again, neither shall we also be So don't worry about trying to understand the topic. Just remember those equations. Now, so the aim of my project was to calculate once and for all the RAU over all locations that are in Zimbabwe so that nobody has to go through those same calculations again. I'm just going to calculate them once and for all over all of Zimbabwe so that every time you want to design a project, despite its location in Zimbabwe, you can simply pick the value of the name of the RAU and now we can go on. Now, these were my objectives. The first thing that I did was to review on PV efficiency models that correlate the wind speed data, the radiation data, the ambient temperature data, and also the multiple configurations of the PV models. And after I take those models, I used them to now come up with 12 band limits. We showed the RAU over Zimbabwe. And also, as a byproduct to this project, I produced what I call the map of optimal duty angles. Now, this is for very important, especially to those who are involved in businesses of installing solar PV modules, because there is an angle, a typical angle, a unique angle for each location that you are able to treat your PV module so that you get maximum all year round energy yield. Now, why should we devote time to this project? I mean, what is the justification? What is the reason for doing this project? The first thing, we need to eliminate that complex process prior to PV system design. And the second thing, we need to easily identify what I call solar bottlenecks. You know, every location has got a unique solar output that you can actually give you. So we need to say, I am an investor, I need those places which have got the highest potential for PV RAU so that I will get the maximum return for every investment that I make. And also the other thing, we need to assist in PV system deployment policy, like decisions like which site or which area is the best to put a solar farm, and if it is a national project. Also the other thing, we need optimal and cost-effective designs, and also I'm going to give you process data, but you know, I'm not going to do it for free, just to create it will be good to go. So another thing also, you know, solar energy is free and it does not bring a bill, so we need to harness it. Now, this is the methodology that I used myself to go through this project. The first part was a review of the PV efficiency modules, and after I selected the best and most appropriate PV module, which was more consistent with the radiation data or the meteorological data that I had, I used a software which is now called PVC. Now, this is a very powerful tool. It's actually a solar photovoltaic energy delivery system design software. And now, using this powerful tool called PVC, I generated, or I fed it actually with the meteorological data for each location, and I did it for 256 points in Zimbabwe. So I would input the radiation data, the temperature data, I also put the wind speed data, I also put the mounting configuration for that particular location, optimizing the tilt angles, and also after I did that, I computed the RAU at a grid resolution of 0.5 degrees longitude and 0.5 degrees latitude. And after I did that, I used another set of software, which is a geostatistical method and interpolation software called Zebra. And using the Kriging's method, I fed the data that I produced using PV system software Zebra, and then I produced 30 RAU maps and also a map of optimal tilt angles. Now, this is now the most important part of the project. And I think you can report with me what you are about to hear is very important. So everybody, please, may you take a seat? So let us see what we point out. Now, before I actually show you the result, here is the table. Try to describe the face of the person. Let me give you some few hints. this person is probably the pastor at your church, or maybe one of your best TV comedians. He's actually a guy who's very handsome. I want you to try and imagine how this guy might actually look like. Okay, let me see how good you are in this. This is the guy that I was trying to show you. But one thing that I can say is that you will know is close to this. Now, the point that I am trying to bring out here is that tables are really not good at representing information. After I did my research project, these are the results that I came up with. This is part of the database of the RAU that I actually created. But if I give you something like this, I tell you that it is actually representing it shows the temporal and the spatial distribution of RAU over the nation. It's something that you cannot really interpret easily. But you know what? Albert Einstein, one of the greatest minds that ever lived, said that everything should be made as simple as possible, but not any simpler. And ladies and gentlemen, let me tell you that with the use of another software, which I mentioned earlier, called Zephyr software, I was able to produce what I call PPR units, and these are now an easy interpretation of the same data. So what you see here, this is what I produced. This is now called PPR units. So what I'm showing here is this figure, which is now called a UIA. So what it is showing you is that how much energy in kilowatt hours are you going to get over any location that you are in Zimbabwe for every kilowatt peak or every 1,000 watt of PV module that you install per day. So what now is if I want me to decide, say I want to decide my photovoltaic energy delivery system in Harare, which is somewhere like all this, the longitude is like 31 and the latitude is minus 70 somewhere here. I simply need to come here and and I compare the color here with the color which is on the scale here. So like in this case for this location, you can see that I can get a maximum of 5.46 kilowatt hours for every 1,000 watt panel that I install over this location. It's about every no longer I need to go through those tedious processes. And now this is a PPR unit for the month of June. And you can see that in June the parts around Kaliba Day, they've got the lowest RAU as compared to the parts that are around Blawayo and also the eastern part of the country. And now this graph is what is showing what I call the temporal variation of the RAU over the country. You see what it's showing is explicitly showing the effects of temperature on the RAU. Like as you can see from this graph, during the winter months, April to June, where we have got colder temperatures here, where we have got the cooler ambient, that's actually when we have got the higher interest. The temperature drops, that's when we actually have got the higher interest. This is actually a ratio which I define to be able to demonstrate this. Now let us come into the map of the annual map. Now what this map is showing is the normalized RAU for the whole year. And now let us see how we can actually apply this big RAU unit. Now suppose that I want to design a solar photovoltaic energy delivery system for my home. I can easily come here and read the value of the RAU to know how much energy I get. Or maybe I am an investor when I want to know the best place for me to site my solar power plant. I can see from this map that if the places that you put the part of the country, they would higher interest compared to places like Harare. So this is useful information which you could not know until you have this RAU gives. Or for example, if someone installs a PV plant in these areas around Figa, and the same person for the same investment installs the PV plant in areas which are around Harare. If we look at the scale, we find that one person is getting 5.55 kilowatt hours per kilowatt peak per day, while the other one is getting 4.65. So what it means that there is a 20% difference in the production that you are going to get. In other words, one person is getting 20% more in revenue compared to the other. And you must know that we have to add in. Now let us talk about innovation. Everything about this project is innovative. Can you imagine? We have moved from this and we have got to that. Also, we have moved now this is the level of optimum put there was tells you by how much you need to keep your PV module so that you can get maximum energy, the yield for the whole route. And now this is the innovation before. This is what we had to deal with before, but now we are doing that. And also we could just present this data in this format, but now we have simplified it to this. Now these are now the recommendations. What I would recommend is that we superimpose the traverse of the national grid with the PPRAU so that we can see the potential of grid injection. And also, we need to do this PPRAU maps for other PV technologies and other mounting configurations, also optimizing the duty levels for each individual line. With this, ladies and gentlemen, I say thank you.
Exactly 15 minutes. Thank you, well done. Any questions? Any questions? Those of you who watched the news last night, they probably invited Donald Trump to come up here. And he wanted to say about climate change. Any questions? Yeah, thank you.
Thank you for your presentation. But I just have one simple question. What is the difference between this project and the project that was done by Zimbabwe in 2013? And I think it's one of the lecturers.
Okay, thank you very much. What to understand the difference between this project and the one that was done by Zimbabwe in 2013? India just to be sitting right behind you. Now, let me come back to this one. What I have here on the board are what I call PPR units. The project that was done by Zimbabwe, it was a project to show the radiation data, the distribution of solar irradiance across the whole of Zimbabwe, especially the temporal distribution of the radiation data across the country. Now, this is what happens. When we have got a solar photovoltaic module or a solar panel just simultaneously, and we need to convert the energy that is incident on that module until it becomes electrical energy. There are some losses that occur within the module. For example, there is the effect of temperature on the emissions of the PV module, which I was showing using these equations here. Let me go back to the equation. Okay, so this is the array unit that we need, right? And for us to get this array unit, first of all, we need to know the power that is coming out of the output terminals of our module. And now I said this power is changing every second because of climatic conditions. How? This is where we see that the relative emissions or the instantaneous emissions of the PV module, it is a function of temperature. So now that means the solar irradiance that was incident on the PV module, it is now being depleted by temperature. Not only temperature, it is also now being depleted by wind speed. Not only wind speed, it is also now being affected by the mountain configuration of the PV module. So if after I take all that into account, after I remove all those losses due to effects of temperature, wind speed, solar irradiance in the mountain configuration, what we are left now with is the actual energy output terminals of the PV module. And that is what we call the PPR unit. So it's like I have done this and I presented it on the map.
Please be brief in your questions, and I'm also going to ask our presenters to be brief also in their response. Any other questions?
Thank you. That's a good project. Can you go to the
normalized view? Yes. My question is not that one. The previous one. Yeah, that is that one. Can you locate Harare and Chilean? And can you explain where would you get wise energy?
We are asking if I compare Harare and Chilean. We are asking why Harare and Chilean. Comparing Harare and Chilean, the two. Okay, let me explain. What happens is that in Harare, generally, we have on higher radiation levels. In other words, I'm talking about the energy that we receive from the sun. But here is the problem in Harare. There is a lot of cloud activity in Harare, which means most of that radiation which was supposed to reach the solar panel, it is going to be reflected by those clouds making in the atmosphere. In other words, I'm saying there's a lot of turbidity that happens in the atmosphere, and a lot of radiation is being attenuated even before it gets to the PV module. Also, if we go to Chile, yes, I agree, because generally the higher temperatures we expect there to have lower RUB values. But this is now what happens. Generally, the sky is clear in Chirezi. So if we now look at the annual RAU today, generally during the winter months, Chirezi is in the colder. So during those months, its RAU values are boosted up because of the colder temperatures. So Kalata so normalize the RAU how normalize the whole year now becomes the average of the winter months and the summer months. Like check this one. If you look in December, this is the extreme summer month. You can see that actually Chirezi is with lower radiation as compared to Arad. But if you come there now in winter, where the temperatures are now low, you find Chirezi having a higher yield than Arad. So now, if it becomes now a cold pollution, you can get it together. Chirezi is. When I was computing my RAU value, this is what I did. You are doing for maintenance of solar panels. If you understand that there are no moving parts of the solar panels, so which means the major thing that we are going to be worried about is the accumulation of debt on the surface of the solar panel. In other words, soil losses, which result as a result of vehicle or pedestrian activity and everything else. So what I did when I was doing this project, we don't have currently in Zimbabwe data which is representative of the soil losses across the country. But in each of these, in each and every one of these things I was talking about, I included the default soil loss value of 3%. So it's like I did the actual power output which we were getting by 3%. I was just saying this 3% I say it is because of soil losses. Was we could actually determine how we can say that.
I have to. We still have one more question? No, I think my time is up. Sorry, my time is up. We still have 2 more presentations to go. From Tanzania, I'm going to ask you to come up front and give us something on using Zimbabwean raw material. Thank you.
all know that markets is not many minerals. Gold, platinum, chrome, you name it. According to the Minerals Marketing Corporation of Zimbabwe, Zimbabwe has 64 minerals which can be exploited commercially. But currently as a nation,
we are exploiting less than 30 of it. Out of the 30 which we are exploiting, what products are we making? Let's talk of orange. Which produces jewelry. Jewelry which is for ladies. What is the contribution to the nation? On a large scale, ladies and gentlemen, Zimbabwe is currently not doing anything with raw material. As we can say, so where are we getting the products which we are using as a nation? We are importing. Thus, we have become a consumer of other nations' products. I can call Zimbabwe is currently in a warehouse. Hence, we are sitting. So are we doing justice to our mineral world? I wonder. Ladies and gentlemen, all protocol observed, I am now a tax industry multiple intelligence student here to present my project entitled Manufacture of Crucibles, Graphite Crucibles, using locally available raw materials in Zimbabwe. This is the crucible which I managed to manufacture. You may wonder, what is this clay piece of pottery? What is it used for? A crucible is used to melt and smelt metals, non-metals, concentrates, and ores, doing fire assays in laboratories, foundries, and even gold processing. Out of those 64 which you have, I only focus on 4. Graphite, quartz,